Hello, today we're going to continue with 2.4, derivatives of exponential and logarithmic functions. It is very important for me to note that there are some things in this section that you do not have to worry about, including logarithmic differentiation as well as hyperbolic functions for the AP exam. So this is a shorter lesson than what it is in the book. So another formula for you to memorize. I know there are a lot of them. The derivative of an exponential function is the natural log of the base times that exponential function. So don't forget the chain rule when you're doing this, but f prime of x is equal to the natural log of the base, which is 4, times 4 to the 3x power, that doesn't change, times the derivative of 3x, which is 3. Okay, so typically you'll see it written like this, just so it's a little bit easier to read. Okay, for the second one, same idea. The derivative is the natural log of the base times that same exponential function times the inner function, so using the chain rule. Again, I like to rewrite it. This might be a little different than the book does it, but we're going to do the natural log of 5 times 2x times 5 to the x squared power. Just a little bit easier to read. Again, you do not have to do that. You can leave it as it is. The AP exam, they do not care, and you're good. Okay. Next one, definition or derivative of a natural log. The derivative of a natural log is 1 over x. Just don't forget the chain rule. Or in this case, we have two functions, so we're going to do the product rule. So we're going to do 1 d2. So the derivative of the natural log is 1 over x plus 2 d1, so the derivative is 1, and then I am going to simplify that because x times 1 over x is just 1, plus the natural log of x. Okay, for the second one here, the outer function is the squared part, so we're going to do 2 times the natural log of x to the first power, so we don't need to worry about it, and then times the derivative of the natural log of x, which is 1 over x. So typically the way you'll see this is like that. Okay, some more practice with that. The derivative of this one is going to be 1 over that whole function on the inside times the derivative of that function. And then I like to write it as one nice simple fraction. So I do bring this together and write it as 3x squared over x to the third plus 1. You're good there. Same thing here. The derivative of the natural log is 1 over. So we're going to keep that 1 over square root of sine of x. We're going to multiply by the derivative. So I have 1/2 times sine of x to the negative 1/2, because I'm subtracting 1, times the derivative of that inner function. So we have to use the chain rule twice to get this. Now, when we simplify this one, it actually ends up being kind of nice. We have actually I'm going to put the cosine of x on top, and then I have 1/2, so that 2 is going in the bottom, and then I have square root of sine of x times the square root of sine of x. That's sloppy, I apologize. Try that again. So this is that one. This one, it's a negative exponent, we're bringing it down. And the square root of sine of x times the square root of sine of x gives me just sine of x. So we get cosine of x over 2 sine of x, and cosine over sine is really just cotangent. Again, once you get here, this is probably good, but on a multiple choice, they'll probably go all the way to cotangent. Let's do one more there. Okay, another derivative. This is actually a formula, and if you remember, we could do a change of the base here by doing the natural log of x divided by the natural log of b. So I'm going to rewrite this as the natural log of x divided by the natural log, and our base here is 10. I'm going to squeeze my d dx in there so I know that they're equal. And I can actually bring that natural log of 10 out because it's a constant, it's a number, and just take the derivative of the natural log of x, which we already know. So the derivative gives us 1 over x. So this is our final answer. Okay. We are taking this problem out, that's logarithmic differentiation. We don't need to worry about this one either. So here's our summary of what you need to know. There's a lot more in this section in the book, but it's really just that first part. And then for your practice, I did change this. There were typos in the packet. So page 187, 9 through 21 odds, and then the rest should be the same. If you have any questions, let me know.